All right, spectrum monitor project. Send it all the way. Okay, device is set to pull data from the USRP on this IP address. Corresponds. These are our default parameters right here. I'll go ahead and define a file path right now. All right, file path is defined, and begin. Okay. FFT power spectrum between the start and stop carrier defined here. Waterfall plot showing a time-based version of this, and it's running. As this is going on, I have signal power detection detecting these data points that exceed this threshold. My threshold set at -40, so any signal that exceeds this -40 threshold is going to get pulled. And I can see here that it's double peaking a little bit, so that's why sometimes I say 2. All right, and this is a diagnostic panel showing what's getting saved to the USRP. So I'll go ahead and stop this now. Go ahead and examine the diagram very quickly. This is the top level diagram for the spectrum monitor. Pull our parameters in, set carriers, all the stuff, read data. So this outer loop is performing, basically starts the whole process over at the end of each data collection cycle. This right here is actually how we iterate through the spectrum. It goes through the spectrum in steps defined basically by our IQ values and our sampling rates, so on and so forth. This loop performs averaging to smooth out the data, remove any outliers, that kind of thing. Once the averaging is completed, we have a good FFT power spectrum that we then send over for thresholding. Thresholding occurs way out here and gets fed back into the system via a shift register. This is where the saving occurs right here. This is just some test output for the diagnostic panels. This right here builds, it basically stitches the spectrum together so that we see that nice FFT power spectrum. This is where we're showing some more diagnostic information. This subblock down here generates the waterfall plot that you see. It can be very computationally expensive to do this waterfall plot. So we do sometimes disable this if we need to run faster. This should be in a disable case structure if we want to disable that. And the thresholding is pulling out certain center frequencies for signals that exceed the threshold level. So the final thing we'll do is look at saving and reading. So we're going to read data from the file we just saved. I'll go ahead and pull that file up. Just so you know, it saves 2 files. There's a helper file that saves parameters and center frequencies and so on and so forth, and timestamp data, all that sort of thing. All right, so let's play it back. And we see here, centered at 100 megahertz, the piece of data that we saved along with the timestamp. Increase the playback speed if we want. We can also pause it during play to examine it more closely. Like so. And there we are. This applies if there's more than one frequency, so I'll demonstrate that real quick. So if there's multiple signals that exceed the threshold, here's how they get displayed. So I see signals at -60, so I'm going to go ahead and set it to -70 as my threshold so that I can get multiple signals on the spectrum. Run this for a little while. I'm also going to time the run. About 10 seconds. And we'll go ahead and check that file read again. We see multiple signals now on their specific part of the band. If I turn this off, it'll just kind of iterate through showing each one rather than showing them all together. So usually we leave this on because it's kind of in development functionality. And these parameters here will bracket what's displayed. Okay. And that is the basic functionality of the project.